Okay, I'm going to work through some of the 2-7 related rates questions. Again, to do related rates, you want to read the question, reread the question, identify what's given and what they're asking for. Draw a picture, write an equation, differentiate with both sides with respect to time, and solve for what they're asking. Now you'll notice, please, that every one of these has rate of. Almost every one of these questions will say at a rate of. But whenever you see at a rate of, that simply means a derivative, which is why these are in calculus questions. So, a spherical balloon in number 14 is inflated at a rate of 800 cubic centimeters per minute. How fast is the radius changing when the radius is 30 or 60 centimeters? So I drew a cube. It's talking about how fast it's inflated, cubic centimeters, at a rate of 800 cubic centimeters. Cubic centimeters is a rate of volume. So that would be cubic centimeters is measure of volume. The measure of time is minutes. So that's given. The dV dt is given. They're asking how fast is the radius, or what rate is the radius changing. So they want us to find dr dt. That's what they want us to find. So what I'm going to do is I'm going to write a formula for the volume of a sphere. I will give you any geometric formula if you need it. It's 4/3 pi r cubed. Now, whether you put the pi on the end or the pi on the top, it's still 4/3 pi r cubed. There's only two variables. I don't need any secondary equations. I just take the derivative with respect to time. 4/3 pi is a constant. Power base, 1 less power, derivative of base. Because it's an r, I put dr dt. Those 3's might divide out, making dV dt equal 4 pi r squared dr dt. Okay, at this point, we know what dV dt is. I know that I'm trying to find dr dt, so I leave it in the equation. And I'm going to plug in what's given. dV dt is 800, so I put in 800. Part A says when the radius is 30, so I put in a 30, and yes, it is squared. So what do you get here? 800 equals 900. 4 times 900 is 3600 pi dr dt. So I'm going to divide 3600 pi, cross out some zeros. What's half of 8? 4. What's half of 36? 18. Let's do it again. Half and half. We could simplify it faster, but we get 2/9. And this is what dr dt is going to equal. Now, if it was in cubic centimeters for volume, the radius would be in centimeters. Time is in minutes. Yes, you need to give units to get these problems correct. Excellent question was just asked. What happened to this pi? I don't know. I lost it. It should be on the bottom. So the answer should be 2/9 pi. 2/9 pi. Be very careful to keep your pi in the denominator if that's where you want it to be. Just don't put it on the end, because if you put it at the end, it's the same as being on the top or in the numerator, and that's not where the pi is. Now, to do part B, all you're going to do is you're going to replace, instead of the radius with 30, for part B, you'd make the radius 60. So for part B, you would have 800 equals what would that be? 36, double the zeros, dr dt. So that's 800 equals 36 times 4, 120, 144, 2 zeros, pi, dr dt. So you would take 800, divide by 14400 pi, cancel those. Half the top is 4, or what goes into both of these? 4, but half the top is 4. Half the bottom would be what? 72 pi. Half the top would be 2. Half the bottom would be 36. So apparently on this one you're going to get 1 over 18 pi for dr dt. And again, it's in centimeters per minute. Okay, after 14, somebody asked me 15. Edges of a cube. So what I'm going to do is I'll probably draw a cube. So I will make a cube something like this. And each edge we'll call E. Volume of a cube is a rectangular prism is length times width times height. If it's a cube, it's E times E times E, or E to the third. Why am I writing a volume? Because it says how fast is the volume changing. So I take the derivative with respect to time. Power base, 1 less power, derivative of base. Since it's an E, it's dE dt. I'm trying to find how fast the edges are changing. Actually, I know d edge dt. I'm trying to find what? How fast the volume is changing. So I'm trying to find dV dt, and I think I'm given dE dt. Anyway, for part A, what is the edge? 2, and what's dE dt? That's what's given. How fast are the edges changing? 6 centimeters per second, according to this. So that's what I put in here. Given, and what am I trying to find? dV dt is what I'm trying to find. So anyway, what do I have for dV dt for part A? 3 times 4 is 12, times 6 is 72, and that would be centimeters. This is volume, so cubic centimeters per second. That should be part A. Now for part B, you're going to take the exact same formula. dV dt equals 3e squared dE dt, which is the same exact formula. But this time in part B, what do I put in for the edge length? Again, I'm trying to find dV dt. What do I put in for the edge this time for part B? 10. What is dE dt given in the first sentence of the problem? 6. So what does that make dV dt? 1800. And volume is cubic, so it's cubic centimeters. Time is in seconds, I believe. So there's your answer for A and for B. Okay, after 15, let's look at 17, I guess. 17 would be the next one, numerical. Anyway, sand is falling off a conveyor belt onto this tank, or into this pile, that is. So it's flowing into this pile at a rate of, so they're giving me at a rate of, that means it's a derivative, cubic feet is volume. So they're giving me dV dt to be what? 10 cubic feet per minute. So that's a given. What are they asking us to find? It says at what rate is the height changing, right? So they want us to find rate is derivative of the height. So is there any questions on what they're asking us to find and what they're giving us? I'm just restating it, making sure everybody understands what it says. Sand is falling onto the conical pile at a rate of 10 cubic feet per minute, so this pile is growing. The diameter of the base is 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? Because it's a cone and it's a volume, I probably should write the volume formula for a cone. Again, I'll give you any geometric formulas. Its volume is pi r squared h. Now they give us dV dt. They give us, we want to find dH dt. So they give us this, they want that. What's the variable that we don't want in this formula? The r. So I need to somehow replace this r. So let's see what we have. Diameter is 3 times altitude. Diameter is 3 times altitude. Diameter is 2 radiuses. Is means equals 3 times the altitude, which is also called the height. So does that tell me that the radius is 3h over 2? So I will replace it in 3h over 2. That's a critical replacement if you ever wanted to write the volume in terms of the height. So you have pi over 3. That would be 9h squared over 4 times another h. Does 3 go into 9 evenly? 3 times, and h squared times h is h to the third. If I had ever asked you to write the volume in terms of the height, like they do on parts of free response questions on your AP exam, there the volume is expressed in terms of height. So I'm going to hesitate a minute, let this sink in, or take some questions. Okay, from here I take my volume in terms of the height, and I'm going to take the derivative of both sides. The derivative of v is dv dt. 3 pi over 4 is a constant factor. I will do power base, 1 less power, derivative of base. Because it's an h, you put dh dt. So that makes dv dt equal 3 times 3 is 9 pi over 4 h squared dh dt. I'm trying to find dH dt. So if I'm trying to find dH dt, I need to leave it in the equation, right? So I left dH dt there. Now what's given? Is dV dt given to be 10 when the height is 15? 15, it's only 15 feet high for an instant. The pile is still growing, right? So it's not 15 for always, just for an instant in time the height is 15. You can only plug in instantaneous values like this one after you take the derivative. I'll say it again, you can only plug in instantaneous values after you differentiate. Regardless, this becomes 10. That's 225 times 9, I think, is 2025 pi over 4. To solve this, I'd multiply by the reciprocal, which would be 4 over 2025. And what does where's the pi? The pi is on this, so 2025 pi. And you're multiplying it by 10. So you get 40 over 2025 pi. I bet this simplifies. So I think 5 goes into 48 times. 5 goes into here, is it 45 times? 450, let's see, 5 times 450, right? and that would be dH dt. Let me check my arithmetic. What would my units be, though? If the volume is in cubic feet, what's the height in feet? And what's the time in minutes? Apparently, I'm not very good at division because it's not 450. I believe it would be 405, right? Because that would give me 2,025, yes. So 8 over 405 pi feet per minute is the answer for 17. Okay, after this one is a conical pile. To make a conical pile, you'll notice that the circular base is on the bottom. It would not be resting on its vertex, as opposed to number 18, which is a conical tank, vertex down. So that's why my cone is oriented this way. It says that it's 10 feet across the top. 10 feet across the top. And how tall? I believe 12 feet tall. So, is that right? 10 feet across the top, 12 feet deep. And what's happening? Water is flowing into this. So let's make the water purple. Water is flowing into this at a rate of 10 cubic feet per minute. Cubic units are volume. Minutes are time. It's a derivative because it says rate of. So that is one of the givens. They give us dV dt. Now what does it say to find? Find the rate of change of the depth. So the depth is the height. So I assume they want us to find the rate of change as the derivative of the height. So again, I think you first want to identify what's given and what they're asking for. Now this is a cone and they're talking about volume, so I probably need my volume formula for a cone. And it is 1/3 pi r squared h. Again, they say they want the rate of change of the depth. So they want dH and dV. So they want h and v. Which one do we not want in this equation? The one that's not mentioned, which would be r. So I might have to use a secondary equation just like I did on this one. Here was my secondary equation on 17. I might have to use a secondary equation to plug in to make it into the two variables that I need. Now, as it's filling up, first off, as it's filling up, it has a water level. It attains a certain water level, and it's going to have a certain radius, and it's going to have a certain height. But the overall large tank has a big height of 12 and a radius of half of 10 or 5. So is there any way we have two similar triangles because of angle similarity postulates from geometry, if you remember that. But I have two similar triangles here. Their sides are in proportion. So could I say little radius is to little height as big radius is to big height? I'll say it again. Little radius to little height as big radius is to big height. If I solve this for r, I'd cross multiply because when you have two fractions equal to each other, you can. And you get r to equal 5/12 h. So I put in 5/12 h. That's the key replacement right there. Now when you square 5, you get 25. That would be h squared and 144 times this h. So what's the volume going to be? 25 pi over 3 times 144, I think, is 432. I'll check my arithmetic. H squared times h is h to the third. Okay, now this is the volume in terms of height. Many times it'll ask you something. I could just as easy ask for the volume in terms of the radius, right? So you'd solve the primary equation for the h, and then you'd have r's in the formula. However, I don't want the r in this one because it's not mentioned. At this point, I'm going to take the derivative. dv dt equals 25 pi over 432 is a constant factor. Power, base, 1 less power, derivative of the base. Because it's an h, I put dh dt. Now, if I wanted to, does 3 divide into 432? I don't know if you know the trick. If you add these digits, I think you get 9. Because that's divisible by 3, that means 432 is divisible by 3. So I know that it is divisible by 3. So I do 432 divided by 3, 1, 3, 13, 4 times 3 is 12, and 4. So I think I get a simplified equation of 25 pi over 144 times h squared dh dt. I'm trying to find dh dt, so I'm going to leave dh dt in the equation. So I'm going to leave dh dt here. And I'm going to fill everything else in. What's dv dt given to be? 10. At the instant, the height or the depth is 8. Again, 8 is an instantaneous value. It's only 8 feet deep at that instant in time, and you can only plug in instantaneous values after you differentiate. So that's 64. Does 64 divide into 144 somehow? Or does this simplify? It must simplify, so just let me give a little room. And let's come back up here. 10 equals, what would that be, 1600 pi over 144 times dh dt. Let me make a little room here. Times dh dt. Let me check my arithmetic again. Okay, at this point I'm going to multiply by the reciprocal to get dh dt, so that's 144 over 1600 pi. When I do that, top times top is 144 with another 0, right? On bottom you get 1600 pi times, let's see, no, I already did that, times 1, so, and multiply here, these cancel, leaving you dh dt. Cross out a 0, let's see what we can do. Half of the top is 72, half of the bottom is 80. 9 goes into, or 8 goes into 72 9 times. 8 goes into 80 10 times. So I think this would be dH dt. Volume is in cubic feet, so height would be in terms of feet, and time appears to be in terms of minutes. So this should be the answer for number 18. 20. A water trough is 12 feet long, 3 feet across the top. Its ends are isosceles triangles with altitude of 3 feet. So let me label this at least. It is 12 feet long, so it goes back 12 feet, 3 feet across the top, and it is an isosceles triangle, so I mark those as congruent. And I think I've got all the information there from the beginning. Now, part A says water is flowing into this tank or trough at 2 cubic feet per minute. 2 cubic feet per minute. Cubic feet is a measure of volume. It's a rate, so it's the derivative of volume. And that's given as dV dt. What are they asking us to find? Well, in this first part A, it says how fast is the water level rising? That is the rate of the height, basically. So I think they're asking us to find dH dt. So again, I think it's important to identify what they give you and what they ask. The volume of a prism like this is the area of the side times 12. So what type of shape do I have? It's a triangle. Half base times height times 12. So the volume is going to be 6 base times height. 6 base times height. Again, volume is the area of the base times how far it is. So it's 12 feet long and the base is a triangle. The area of the triangle is half base times height times 12. So I have a dH dt and dV dt. I have H and V up here. Which do I not want in this equation? B. So this is another one that might involve a secondary equation. And I might have to replace B with something. Now, if I looked at my triangle, I'm going to erase this, so if you want, write it down. It says it was 3 feet across the top and an isosceles triangle, correct? And if you drop an altitude here, it says altitude is 3 feet also, right? So that makes this 3 in the top, I believe, becomes half of 3 and half of 3 if you were to divide it. Is that correct? And let's see, could we do Pythagorean theorem to find the missing side? Leg squared plus leg squared equals hypotenuse squared. So 9/4 plus 9, what is 9 in fourths? Is that 36 over 4 is 9? And so what does that give me? 45 over 4, I believe, for h squared. So what does that make this side? I'm not even sure we need this side, so I'm not even going to bother with that. I apologize. I think I was spinning my wheels, because I only want the base and the height. At a I don't even think I need to split this. Very conveniently, the base, it's going to have a generic base as the water level's rising, and it's going to have a generic height. Again, similar triangles. Small base to small height as big base is to big height. And it just so happens that the base equals the height. Why? Because it's 3 feet across the top, 3 feet high. And that proportionality will always mean the base equals the height. So the base could equal the height. I said I had to erase that. So what does that make the volume now? I believe volume is 6h squared. So dV dt would be 6 times 2 is 12h dH dt. I hope I can start skipping some of the steps, like that's 6. How fast is the water level rising? So we're looking for dH dt. Excuse me. What are we given? dV dt is given up here to be 2 cubic feet per minute. At the instant, it is 1 foot deep. So you get 2/12 or 1/6 of a foot per, what is it, minute, is dH dt. Sometimes they might write it as 2 inches per minute. How are they getting 2 inches? What is 1/6 of a foot? 2 inches. I'm not big into forcing you into unit conversions like part B is, because you'll notice B changes measurements to inches. But anyway, this is your answer for part A. Please try part B, or I'll go through part B momentarily. But that's part A. I'm going to erase it to get to part B. Okay, for part B, I'm going to erase some of this. So let me get rid of some of this down here. I think it's still the same dimensions. We still have the same proportional. Base still equals height. So I think I'm still at this formula. I still think dV dt is going to equal 12h dH dt, just like we had before. But this time they want to determine the rate at which water is being pumped in. So they want us to find dV dt at a certain instant. Now it says 3/8 inches per minute. 3/8 inches per minute. How can I change that into feet per minute? Okay, this is 3/8 inches per minute. I would like to change it into feet. So I'm going to multiply by a fancy form of 1. 1 foot equals 12 inches. Now would the inches divide out, giving me what? 8 times 12, 80 and 16, is it 96? And that simplifies into 1 over 3 goes into there, 32. And that would be in feet per minute. So that's dH dt now, because that tells you how fast the water is, right? So it's 1/32 is what I'm going to put in here. And it says when the height is 2 feet. So I put in 2. So what does that make dV dt? 24 divided by 32. 8 goes into there, 3, and into there, 4, because now I'm in feet. But volume is cubic feet. So it should be 3/4 cubic feet per minute for part B. Please give these an attempt. Again, you really got to try these on your own. Try some of the other problems. Bring in some questions.